Hello, my name is Patrick Niebuck, and in this tutorial I'm going to show you how anisotropic reflection works inside Thea Studio. So first question is, what are anisotropic reflections? Well, reflections that are stretched or distort in one or another direction. So, and what causes this kind of stretch reflection? Well, again, the property of the surface of the object. So let's have a closer look. The fine peaks and valleys of the surface causes the reflection to be uniform if the distribution and height of the peaks are more or less equal. But if the difference in height of the peaks creates a directional pattern, then the reflection of the surface will be anisotropic. Here we can see a close-up of brushed metal. Notice how the reflected light gets stretched in the opposite way of the direction of the grooves. Here also can show anisotropic reflection. Even if a single hair strand doesn't have any anisotropic reflection, the directional pattern created by all the hair strands together produces this effect. Let's see how this works inside Thea Studio. So let's get started. Before we can use the anisotropic reflection, our object, in this case this plane, needs to have UV coordinates. What this means is that you have to map a texture to your object. In this case, it's good to map a brushed texture so you can see the direction of the grooves. In this case, the reflection will be the opposite way, it will stretch this way. If it happens that you map your texture the other way around, vertical, then the reflection will be stretched horizontal. So this is also a good way when you're in your modeling program to know in which direction the grooves go. So once you have created UV coordinates, they're ready to go. So let's delete this and let's start. So right now we have a roughness of 0 and no anisotropic. So you can see it's a clear mirror. Let's add a value of 10. And we can see our reflection gets stretched vertical because the grooves are horizontal. But you can also see that we don't get any blurring in the horizontal direction. So even if we increase this to 20, the object gets less visible, but can see still the shadows. The blurriness is not happening on the horizontal, on the x-axis. So to control this, it's actually the roughness 0. So if we increase the roughness 0 to 5, so we are affecting now also the horizontal direction here, and the object gets more blurred. So with these two controls, you can control the look of this anisotropic reflection. Now, often you will see like brushed metals that there are visible scratches, because right now here you don't see any visible scratches. It's very smooth, everything. And there are several ways you can add this detail to the material. Now, one way is using, again, the scratch map. Now it's way too strong, so let's lower this value, let's say to 10, or even lower, let's say something like 5. And you see it's also very big. Let's reduce this by tiling the texture, let's say 10 times. You can see, okay, you got some variation, but the texture is too small and you can see repetitions. So in this case, it is better to use a texture that is big enough so you don't have to increase the tiling so much. So let's get this back and use a different texture. Okay, this one seems to be much better. It's a little bit weak. I don't know if you can see this over the video here. But we can also use the tone mapping here to increase the contrast and maybe lower the gamma. And yeah, now you should see it a little bit better. Now we get some visible scratches also. You are not limited to use the bump map here. We can also, let's copy this one, delete it from here, and instead of using it in the bump map, we use it in the anisotropic channel. So we place it over here, and you can also see that we're getting here some imperfections, some visible scratches. So you can combine it. You can also, instead of using it here, using it in the roughness channel over here, or even in the reflectance. So there are many ways to really get the look you're after for brush metals or any other kind of anisotropic reflection. So now let's delete this. And anisotropic reflection can also happen without using the anisotropic value. I'm going to show you a small example. We'll stop here, and I'm going to change camera. And you see we have here a tube, a fine tube. And if you remember the example of the hair, well, this tube, let's put the sun in a nice position, and let's render. You see, we have reference 0, anisotropic 0, and we can see here the sun reflected. So if we take this tube, let's put on the handles again, and let's say we duplicate it and move it slightly over, we see again the sun reflected at a different angle. So what would happen if we duplicate this much more, hundreds or thousands of times, like with the hair example? So we can kind of set up here on the other layer exactly that. Let's have a look. You see, here is the anisotropic reflection of the sun, and this also happens on rainy days. You can see anisotropic reflection on the street because the bump, the unevenness of the street also can produce this with water over it, so it's very reflective. Or even the ocean. On sunset, you can see that the reflection of the sun is like, yeah, similar to this beam. So, yeah, there is another type of anisotropic reflection. We will have a look right now. In this example, we can see anisotropic reflection created by a circular pattern on the volume knob. And on this other example, we also see anisotropic reflection created by a different type of circular pattern. Let's see how this can be made inside Thea Studio. So to get our circular brushed metal, first we are going to add a metal to this part over here, and you see we have roughness 10, and can give it now anisotropic reflection. But right now, if you render, nothing will happen. Look, you see, there is no circular pattern. For this, we have to use the rotation. Right click and use a procedural texture for it. And immediately we see we have, again, the object needs to be UV mapped first. And yes, again, we can control the sharpness in one direction or the other with these two values. So setting this here to 0, see frictions are quite sharp. I prefer to have it a little bit softer. Can go even 20. Is a very nice look. Now, the other type of circular pattern can be achieved by, we also take the aluminium again, drop it here, and give anisotropic of 50. 50 you can use whatever you want, it really depends on the material. After you can go out to 100. And in this case we have to use a different Bushido map, which is this, the concentric. And you see right now it's big, so we go to the coordinates, and let's say do the tiling of 15. And here we have it. You can see that we get a very nice pattern, exactly like we saw on the rear photo. And the rotation value also serves without using a texture in case you have set up your UV coordinates in a direction you later on say, oh, I prefer it would be the other way around. You just type in the value, 90, 45 degree, whatever you want, and the Thea will rotate texture for you. So again, like with all the other values which have a texture channel, you can use for rotation also a bitmap. Knowing that in Thea black color means 0 and white is the full value. In this case, as it's in degree, it's 360 degree. So white will be 360 degree and black 0. And all the gray values in between will correspond to the degrees. That's it for anisotropic reflection. I hope you liked it. Hope I see you the next time. Bye bye.